For most of history, Neptune was invisible, a ghost in the solar system's cold, dark outskirts. Even after its discovery, it remained a faint blue dot, mysterious and distant. Named for the Roman god of the sea, its deep blue color was all we really knew. Unlike Mars or Jupiter, Neptune didn't capture our imagination. It was too far, too faint, too cold. Its year lasts 165 Earth years, and sunlight there is 900 times weaker than on Earth. We assumed it was a static, frozen world, just a ball of ice and gas. Observing Neptune from Earth is like trying to read a coin's fine print from a mile away. For over a century, it was just a smudge of light, its details lost to distance. We saw a serene blue orb and assumed it was peaceful. But the universe loves to surprise us. Neptune, the quiet, distant world, was hiding a wild personality. Beneath its tranquil blue facade was chaos, strange energy, and winds faster than sound. The planet we thought we knew was a stranger. The James Webb Space Telescope was about to reveal Neptune's true nature. The quiet kid in the back of the class was about to speak up. Neptune's story was about to change, forever. What we would see would challenge everything we thought we knew about ice giants. The forgotten planet was about to become the most intriguing. Neptune was ready for its close-up, and the universe was ready to listen. Neptune's discovery began with math, not a telescope. Astronomers noticed Uranus was wobbling. Something unseen was tugging at it. Two mathematicians, Leverrier and Adams, calculated where this hidden planet should be. Leverrier sent his prediction to Berlin Observatory. On September 23, 1846, Johann Galle pointed his telescope and found Neptune almost exactly where the math said. It was a triumph of human intellect, a planet found by calculation, not chance. But finding Neptune was just the beginning. For 140 years, it remained a distant enigma, big, blue, and far away. We knew its size, distance, and its largest moon, Triton. But the planet itself was a featureless blue ball, too far for details. Our understanding was limited to a point of light, discovered by reason but defying observation. The mathematical victory gave way to a long wait for better technology. Neptune's secrets stayed hidden, waiting for a closer look. The world found by math would eventually demand a new kind of exploration. It was a puzzle, waiting for the right tools to solve it. The next chapter would require more than just numbers. It would need a mission across the solar system. The age of discovery was only beginning. Neptune's true nature was still out of reach. Voyager 2 changed everything in 1989. After a 12-year journey, it gave us our first real look at Neptune. The planet wasn't calm. It was dynamic and violent. Voyager 2 revealed colossal storms, including the Great Dark Spot, an Earth-sized hurricane. Neptune's winds were the fastest in the solar system, over 1,200 miles per hour. Voyager also confirmed Neptune's faint, clumpy rings and discovered new moons. Its magnetic field was bizarre, tilted and offset from the center. Neptune was weirder and more extreme than anyone expected. But Voyager's visit was just a flyby, a snapshot in time. The Great Dark Spot vanished when Hubble looked years later. New storms appeared. Neptune was constantly changing. Voyager's glimpse left us with more questions than answers. We needed a way to watch Neptune's story unfold in real time. The mystery deepened, and the wait for new eyes began. Neptune's secrets were far from revealed. For decades, Voyager 2's images defined Neptune. But we needed a new perspective. Enter the James Webb Space Telescope. Webb sees in infrared, revealing Neptune's heat and hidden layers. Its first images showed a glowing orb with bright, crisp rings, clearer than ever before. Webb tracked high-altitude methane clouds as they formed and faded in hours. It's like having a weather satellite for a planet 2.7 billion miles away. Webb revealed a swirling vortex at Neptune's south pole and a mysterious polar brightness. These features were never seen before. Webb's data is probing Neptune's hidden interior, showing atmospheric complexity that defies old models. The quiet blue marble is gone. In its place is a dynamic, glowing, and strange world. Webb has opened a new chapter in Neptune exploration. The first pages are already rewriting what we know. Neptune is no longer a static mystery. It's a world in motion, and we're finally watching. Webb isn't just taking pretty pictures. It's diagnosing Neptune's deep strangeness. Neptune radiates more than twice the energy it gets from the Sun. This heat can't be explained by slow contraction alone. Webb's data shows Neptune's interior is chaotic and turbulent, not neatly layered. This churning could be the source of its extra heat, a planetary furnace stoked by unknown forces. Neptune's magnetic field is also bizarre, tilted, offset, and complex. It may be generated in a shallow shell of slushy, conductive ices, not a deep core. Webb's observations are helping refine our models of this internal dynamo. Webb also detects faint radio signals, whispers from Neptune's magnetosphere. Some signals don't fit standard models, hinting at unknown processes. Neptune's heart is sending out strange broadcasts, challenging our theories. It's not just a planet, it's a puzzle box. The more we look, the stranger it gets. To understand Neptune's interior, we must imagine matter stranger than anything on Earth. Deep inside, water, methane, and ammonia become exotic ices under immense pressure and heat. One possibility, supersonic ice, where oxygen forms a solid lattice and hydrogen flows like a liquid. This bizarre, conductive state could generate Neptune's weird magnetic field. The supersonic ice layer, close to the surface, might explain the lumpy, offset magnetism. Even stranger, methane could break down into carbon, forming diamond rain deep inside. These exotic materials are the engine of Neptune's chaos. Webb's data is helping us piece together this alien interior. Neptune's heart is a laboratory of matter found nowhere else. The planet's strangeness is only beginning to be understood. Neptune's weather is a paradox. Supersonic winds on a planet far from the Sun. Unlike Earth, Neptune's storms are powered by internal heat, not sunlight. This heat rises, creating massive convective currents and ferocious jet streams. Neptune makes its own weather, almost independent of the Sun. Webb tracks bright methane ice clouds, mapping winds and storms in real time. We see storms born, grow, and get torn apart by the planet's wild atmosphere. Neptune's weather is a boiling, multi-layered system, more like a cauldron than a calm sea. It's a unique laboratory for atmospheric science. Neptune breaks the rules, forcing us to rethink how atmospheres work. Its dynamic interior blurs the line between planet and atmosphere. Neptune's weather is rewriting planetary science. Why care about Neptune? Because it's a blueprint for the most common planets in the galaxy, mini-Neptunes. These worlds, larger than Earth but smaller than Neptune, are everywhere. Neptune is our best local example for studying them. Webb's discoveries about Neptune's chaotic interior, internal heat, and wild weather are fundamental. Many exoplanets may be just as dynamic and strange. Neptune teaches us not to judge a planet by its distance or appearance. Its story is a lesson in cosmic humility and surprise. We started with a faint blue dot, thought to be cold and dead. Now we see a world alive with storms and exotic matter. Neptune is no longer forgotten. It's a gateway to understanding worlds across the galaxy. The quiet giant has finally spoken, and it's changing everything.